much of our lives is shaped by what is remembered. Missing an old friend spurs that long overdue phone call. Running out of your favorite coffee is something you preferably want to remember before your grocery run for the week. I'm here today not only because the wonderful folks at PAI thought it was a good idea, but also because I remembered to get here and on time. Our lives are shaped by what is remembered. Memory is foundational to how humans act. What is remembered informs what comes next. And so it's been very surprising that in our interactions with personalized AI systems or action-taking agents, surprisingly little attention has gone to what these systems remember about us and how we can shape their memory to control what they do so that AI systems are built and deployed responsibly. Which is lucky for us, is why we're all here today. So let's dive right into it. What is AI memory? Interactive AI systems are being built today to store and retrieve information about users, about a variety of different things to serve different goals. This memory is exactly what enables an AI system to remember a user's preference, to carry over context from one conversation thread to another, and to, in some cases, even improve its own performance over subsequent tasks over a period of time. But memory isn't only what an AI system remembers. It is also about how it is stored, how it is updated, how it's going to be used, over what time horizon, and it even, whether or not that information was directly provided by the user or inferred on behalf of the user by the AI system. So as researchers are examining new ways in which AI systems can be built to remember events in time and space, the emerging architecture of AI memory is poised to shape how these AI systems personalize, learn, and behave. But the more that AI assistants can remember, the more is at stake for when they fail. Already, we are observing many reports that show that AI agents and personalized AI assistants have conducted unauthorized financial transactions, leaked private chats online, and even been linked to emotional and mental harms for vulnerable populations, especially kids. A good question then to ask at this point is, can we shape the underlying memory design and architecture of AI systems to constrain their risk surface? And I'm going to give you a spoiler alert for the rest of my talk that we can and we should. Some of you might be wondering, how is AI memory different from what we've already seen in these digital spaces before in terms of user profiling and privacy issues that have come up? It's a great observation. While it's true that some of these issues aren't new, memory-enabled AI systems blend these issues in new and more entangled ways. Today's AI assistants merge everything that a model knows about the user, conversation history, their preferences, contextual cues, and blends it into one fluid memory space. Data that used to once sit in separate permission silos now pools into a kind of a data puddle. So all your structured and your unstructured information is sitting under one lock. What does that do? It combines the harms in a manner that not only changes the scale of the challenges, but also the texture of the problem. Consider this. Purpose-limited data, like in the health or financial context, could spill into other contexts where it was never meant to appear. So imagine if details from your chats around a health issue actually merge into a context that is about work, and it ends up inadvertently disclosing a health issue or a disability to an employer that you never intended to do. And if AI systems are going to act with more autonomy, as we're talking about AI agents, upon this puddle of memory, by connecting to several external tools and apps to execute tasks, the risk surface is only going to expand. So even a single privacy breach or a single prompt injection could expose the entire universe of information about the user. Even the idea of like memory itself, with its like deeply human-like resonance with the idea of recalling and remembering, reframes the conversation around privacy and personalization. Users might, rightly so, expect to have more control over what is remembered about them. When so much of like who we are as people, how we interact with the world, what we do, is shaped by what is remembered, it also warrants asking the question, who owns my memories? And under what circumstances, if any, can my memories be accessed or acted upon without my awareness or without my consent? For instance, this is not hypothetical, some industry folks have suggested treating certain chats as privilege. But in reality, law enforcement can still subpoena system records. Another example is that to prevent mental or emotional harms, companies may actually be motivated to, or in some cases even obligated to, piece together signals of user distress over time in order to alert public authorities or even family members. Memory considerations are here to stay. So where does that leave us? Allow me to take you on a little bit of a journey. My previous background working in poverty alleviation programs taught me that despite best intentions, it is impossible to solve all problems at once. When facing a complex policy issue, the key is to identify key levers that you can actually move. Think about like points of governance or interventions that are 1, intelligible, 2, actionable, and 3, that can have an outsized impact that is force multiplying. So you need to really look hard for actionable solutions that can help you do most with the limited resources that you have. For example, policy leaders, different tangent, relevant, have focused on interventions like improving childhood nutrition, not just because it improves healthcare outcomes, which is an important thing in and of itself, but also because it has been shown to increase children's school attendance, which then has links to increasing learning outcomes, which relates to employment and even like gender equality issues. So it is for us, as we find ourselves today at one of the most critical points, looking at this challenge of building and deploying responsible AI systems in a manner that preserves user safety, their well-being, their rights, that we too need to find the most effective levers for AI safety with the resources that we have. I offer that AI memory is one such lever that helps ground conversations about responsible AI that might otherwise feel abstract. We need to examine AI memory as not just a technical feature of AI systems, but also as almost a governance surface. Think of it like a technological entry point that can also serve as a convening space for policymakers, companies, and civil society to make AI systems safer. And at its most basic level, all of us interested in responsible AI today must push better to understand how memory works, examine the different ways in which these questions around it are going to be implemented, and responsibly shape how much control and visibility users have over it. Doing so, I'm very convinced, can generate outsized, cross-cutting benefits which are bound to produce effects that can extend far beyond any single system. Thank you.
And the good news is we're not just calling to action and pointing out this problem, we've actually started that process. And that's because we've moved past whether these systems are going to implement memory to how they're going to implement memory. There's still time to bake in design choices and architecture choices into the process and really shape that governance surface that Ruchika talked about. Because the choices that developers make today and how they implement this feature will determine what paths are available down the line once we maybe remember or realize what the implications of those choices are. And we want to make sure that we're leaving as many options open today as we can, even if we're not all ready to make the choices now that we think we might need to. So we started this thinking process. So a few weeks ago, CDT convened a workshop together with Microsoft's Office of Responsible AI, bringing together experts from these past conversations about data protection, privacy, but also frontier model measurement and evaluation to think through what are the implications of memory today and what are those architecture choices that are presented to us that we can influence now. What recommendations should we be making to product teams as they build these features in? We established that the complexity of AI memory, the combination of history and preferences and chats, and the combinatorial harms that all of that produces are going to need technical interventions to control. They're going to need a governance layer that actually helps implement what data can be used in what context, what memories are appropriate to act on, when and by whom, with what notice. And the problem is systems today are not necessarily being built to enable that. So 3 themes that I'll highlight now. We'll have more coming out soon, the readout from this workshop, but 3 I'll talk about today. So first is we need to build that right foundational architecture. Foundational investments in privacy-aware infrastructure can be difficult to make the case for in companies. It's hard to kind of explain what the cost of not doing that today is. But what's interesting about frontier AI is there's now a central system and an investment up front that can help amortize those costs over a long period of time, which can maybe jumpstart the investments that might otherwise have taken years to make. And because we know it's more expensive to go back and do this once these systems have been running for a few years. And from my time in industry, I know that's a whole of company effort over years to re-architect data storage and the communication between different data systems over time. So we know that now we can start again with these new systems. Memory itself will need to be captured in a way that contains information about those contextual permissions. When was memory created? Under what conditions? With what limitations? And that might need some kind of memory provenance or memory metadata that will go with memories, both within one institution's architecture, but potentially flowing through systems as agents are interacting with one another and sharing context in order to accomplish tasks. And memories that involve sensitive characteristics or information are probably going to need ways to constrain their use to certain parts of the conversation or certain domains, but right now they're all in that data puddle that we talked about, difficult to pull back. So what can we apply today? Maybe we'll need content or thematic related classifiers to be able to action some of those and create barriers around them, but building that infrastructure from scratch will be useful down the line. Now, this might sound like an unsolved wish list of unsolved technical problems. Machine unlearning and model explainability of what drove different decisions are still active research areas. But there are different architectures that can better enable these interventions than others. So in our exploration of AI memory, there are different methods to implement them. One approach is to just throw all the personal data, user interactions straight into the model through personalized fine-tuning or parametric updates. But there are also non-parametric ways to implement memory through retrieval augmented generation, vector databases, chat transcripts, et cetera, which might be more controllable, certainly in the short term while we're shaping the constraints of what memories can be used where. And so it seemed to the group who met that parametric approaches to memory might be incompatible with some of the needs we have right now around how AI systems operate. And so what choice might we need to make right now to ensure we don't throw everything into that one pile? And at the moment, our understanding is that a lot of implementation of memory is in that simpler, non-parametric way, and that might be worth continuing to invest in, at least for the time being, until we can better trust that models themselves can understand and navigate context, which it might appear that they can, but I think the consensus in the room was that we're not ready to rely on models to make these determinations around when our memory is appropriate to draw on in what contexts. So the second theme is, just as traditionally conversations around data privacy and personalization have underscored, we can't rely on user notice and consent to account for all of the harms that are likely to manifest. But at the same time, if those tools are offered, which they should be, they should work. And right now, the implementation of memory is so confusing, often implemented in multiple ways, whether chat transcripts, summaries of chat transcripts, factoids that are extracted into memory databases, retrieval augmented generation to external databases. that controlling one surface doesn't necessarily control the information that users think they might be constraining. And so investment needs to go into better linking these different entities, enabling people to understand what's being collected about them, and expressing their preferences around how that information is used. Again, that's not the solution, it's the bare minimum. AI could potentially help innovate in the area of user notice and consent and control and understanding, creating new conversational interfaces. But again, those things should accurately link to the architecture of the system and not just affirm that an action has been taken to protect the user that doesn't actually carry through all of the elements of the system. And at the moment, user privacy controls are, and pardon my technical language, a hot mess. Finally, we need to recognize that the integration of AI memory actually fundamentally challenges some assumptions we have around AI safety at all. How can we evaluate the capabilities or behavior of systems when those systems will update themselves dynamically as they interact differently with every single user who's using them and one another? Personalization fundamentally alters model behavior, so static evaluations and benchmarks are only going to tell us so much. We need to be implementing ongoing monitoring infrastructure, thinking about enabling access to external researchers who can be envisioning and spotting the ways in which these systems act in ways that honestly should probably be pretty predictable today, given what we know about personalized systems, but nevertheless might end up not being prioritized in developers' choices of what to evaluate systems for. And certainly there are constraints themselves. It's hard to evaluate personalized systems before they go out and kind of start updating themselves, but that infrastructure is going to need to exist. And deployers might already find it intuitive to remeasure, reevaluate models if they've been updated through fine-tuning. But if the introduction of memory, even through these non-parametric approaches, affects model behavior to a similar degree, we should be building in a norm that reevaluating these models when integrating memory is an expected practice on a regular cadence. And so as memory kind of pulls in all of these considerations, these kind of echoes of previous conversations, new motivations, maybe new communities who are willing to get involved with this new frame, I think this is, as Ruchika said, a time we can act on a very concrete problem that developers are facing today. This is an issue we're talking about actively at CDT. We're going to be putting out some readouts of these conversations, but we'll be working on it in an ongoing way. So please come reach out to us if you're interested, if you're doing work in this space, and we would love to be connected.